Okay, let's get started. Good afternoon. Everybody having a good conference? Good, good. How many of you have been playing around with Server 2012 so far? Good, 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 very good. So my name is Bob Combs. I'm from the Windows Core networking team, program manager for Hyper-V networking. So we're going to talk about what we've done to support the cloud. We're going to talk about all the new performance features we put into it. And we're going to organize this in a way that will hopefully be a little bit entertaining. What I hope you to take away from this is a little bit better understanding of what we've done and how you can use some of these features to get the performance that you want out of your systems, where the optimizations are, and hopefully a little bit of understanding where optimizations may not be the right thing to do. So let me move ahead. So you've probably seen this slide several times. These are kind of the key pillars of the server. And just to give you a anchor as to where what we're talking about, we're really talking about beyond virtualization. Because obviously when you're talking about the cloud, you have to be talking about virtualization. But it's not just about virtualization. It's also about providing multi-tenancy isolation, making sure that the functionalities that you have in the physical network and the virtual network are transportable, if you will. So just a quick little background. Of course, there's an evolution of the cloud. And it all started, of course, originally with servers, just standalone boxes. And you've all probably lived through this anyway. And then obviously, as we needed more and more servers, we went to the traditional racks of servers, each running separate hosts. But that wasn't quite enough. So I said, let's virtualize. And so things like Hyper-V came about to let you virtualize and move those workloads around on the different machines. And indeed, that brought the cost down, made it more flexible, let you utilize your resources a little better. But there's a next generation, and that's really kind of what we're talking about, the cloud, be it a public cloud, a private cloud, or even a hybrid cloud. Actually, this would be a good point to ask, too. How many of you have a virtualization structure right now that you're looking to move potentially into the cloud? Okay, good fair number. Excellent. So let's talk about some of the key points that you need with a cloud. Well, one of them, of course, is that you have to be able to have some multi-tenancy. That is, I need isolation, that I can have one set of tenants and not working together as itself and not having any bleed over, if you will, into other tenant networks, so that everybody can be running their workloads in a transparent mode. And of course, another thing is you want reliability, right? After all, if you're going to start putting multiple things on a machine, you want to make sure that if something happens, some piece of failure, that you can easily recover and continue running your workloads wherever you need to run them. And that applies to networks as well as storage, as well as the processor itself, the network infrastructure, even the power of your data center. As I said, security isolation, but sometimes it goes a little bit more than that. Maybe you also want to have some kind of filtering. I mean, there might be instances where you want to actually have communication, certain types of communication. For example, say maybe one tenant wants to be able to do web access of a second tenant, but it shouldn't be able to look at any of the other resources. So there should be some ways to put security in for that as well. And obviously, predictability. In other words, we translate that down to networking. What that really comes about is I need to have a way that I can make sure that a particular virtual machine or a group of virtual machines don't exceed their resources. In particular, with networking, we're talking about bandwidth. So I want to make sure that the bandwidth can be shared fairly and equally among different machines. Should have gotten some European speed limit signs. Okay, so administrators in the cloud, of course, want to be able to manage these things, and they want to do it in such a way that they can easily scale the machines. And what that translates to is being able to add multiple VMs within the same machine. That's really your scalability point. But being able to read those resources and monitor what's going on in such a way that you can, at any point, make decisions about where things should actually be running if you need to. And so obviously you can automate a lot of that as well. And one of the new things that we're doing is we've actually made the system extensible. That is, there are times when you want to plug in a virtual appliance or some kind of security device that sits not just between the host and another host, but even within a host between virtual machines that are different tenants. So that's the kind of extensibility. We're talking about making the switch extensible. So, how many of you remember a book called The 7 Habits of Highly Successful Managers? And there have been a lot of people who've done parodies off of that. I'm about to do another one, and I apologize. These are the 7 habits of networking. So, level set a little bit. We are talking about the Hyper-V switch and the network and the physical network underneath that, as well as the virtual machines. And pictorially, you see we have virtual NICs. Those are each of the VMs has its own virtual NIC, a software contrivance that talks to the virtual switch, which again is a software switch, talking to the physical NIC, or it could actually be multiple NICs if you're talking about NIC teaming, and talking to the rest of the physical network. So kind of, this will help you with the nomenclature a little bit. I tend to call the virtual NICs either virtual NICs or VM NICs because it's the NIC for the VM. If the virtual NIC is actually talking to the host directly, that is the management OS connection, then I tend to refer to that as a VNIC, not a VM NIC, but a VNIC, a virtual NIC, talking to the local host. And we often talk about the physical NIC as being the PNIC, P for physical. I'm just trying to brief you ahead of time in case I slip and use those terms. Reliability. Okay, so let's talk about the first habit. So for networking, what reliability centers around for us is being able to do NIC teaming. And that's really one of the big things that we've added in Windows Server 2012. I know that every NIC vendor and several of the OEMs have their own teaming solution. They all had issues that we kept hearing from you folks. Gee, I want a single management interface to manage it. Gee, I'd really like to be able to use different manufacturers' NICs. I don't want to be locked into buying one manufacturer's NIC all the time. And so Microsoft went ahead and said, okay, we will do NIC teaming. And we have our own LBFO admin GUI. You can actually get to it if you start up the server manager. And you select the local server, you'll see that there is listed over on the left-hand side NIC teaming, and it'll say either disabled or enabled. If you click on that, it will essentially launch the executable called lbfoadmin.exe, and that will bring up the GUI and let you manage the team. You can create the team, you can watch the team, you can add NICs, remove NICs, etc. So essentially, the characteristics are that it's vendor agnostic. You can use anybody's NICs that you want. As long as it's a Windows certified driver, it is acceptable to the NIC teaming software. I should mention that you really do want to make sure that the NICs all have the same speed. You can take a 10 gig and a 1 gig NIC, for example, and team them, but you will not like the way that it does the load balancing because it doesn't know how to separate between 1 gig and 10 gig. It also it has some other limitations that it wants to enforce, but generally, you've got both switch dependent and switch independent modes that you can use for the configuration. There are both address hashing and Hyper-V port hashing modes that you can set it in. And the address hashing will use either a 4-tuple, a 2-tuple, or a MAC address for its hashing. If you don't actually set the mode on it, it will automatically drop into the different levels itself. You know, it'll try a 4-tuple, it can't do that. It'll try a 2-tuple. If it can't do that, it'll do a MAC address. Now you might ask yourself, well, gee, why wouldn't it always use a 4-tuple or a 2-tuple? Well, what if you're doing, you know, UDP or ICMP type stuff, and, you know, for example, and you wanted to, you know, so in that case, you know, it's not going to be able to use the IP addresses. It'll also work in either an active-active mode, that is, all NICs are active and you get an aggregate bandwidth, or it will allow you to do an active standby, so that you could have a failover NIC waiting there but currently not being used. So here's a pretty common configuration. Here's an interesting thing. You'll notice here that we've got 2 VM NICs off of the Hyper-V switch, and we've got 3 VNICs to the host being used for different type of work. For example, live migration or storage or management of the system itself. And the 2 10-gig NICs on the bottom are teamed up, and then all 5 of these connections are now being funneled through the NIC teaming software. And you can set bandwidth limits on the Hyper-V switch itself to actually slice and dice this traffic. I'll talk a little bit more about that in a few minutes. This is an interesting statistic, by the way. That, you know, we found about 75% of the customers are actually using NIC teaming, whether it's a Hyper-V server or not. Even standalone servers, it's pretty common for people to use NIC teaming. But that's a good question. How many of you are using NIC teaming in your... Yeah, I think the 75% holds. Yeah, that's good. All right, let's talk about security. So there's a couple of different things that we've done around multi-tenancy. There's different ways to provide multi-tenancy. It's essentially an isolation mechanism. So one of the things that we added to the switch was we said, well, let's add in ACLs. That's one of the things you can do with a real switch, right? So software switch should be able to do the same thing. Let's put in ACLs. ACLs allow you, can be either allow or a deny. And they can use either an IPv4 and IPv6 address, or they can use the MAC address. And so that's configured usually through PowerShell. There are other ways to do it. We do have wildcards in the addresses. That is, I could say, you know, IP address /24 kind of idea to do a mask for the address. And that becomes very handy if you've got different subnets and you basically want to apply ACLs by subnet. There is one other thing that I'll mention, and that is the counter. Do we have something here? Sorry, yeah, there we go. We implemented counters, special counters, and we implemented them as a special case ACL. And I'll tell you why. Here's the situation. Suppose that you have in your enterprise a division of traffic, and you're concerned that a particular virtual machine or maybe a set of virtual machines are going to attempt to use different, I don't know, let's say maybe how much internet traffic, or maybe how much traffic is going to storage, or some other, you know, internal use of a SQL Server base. You can actually give an IP address and tell it that that's a counter, and it will, the ACL will actually, this is a special case ACL, will go ahead and count that up, and that can be read periodically. Not only that, but we did some extra work in conjunction with the Hyper-V team to make sure that if you migrate the VM from one host to another, that the counter values for these ACLs move with it. So now I've got a way that I can track, and I can say, okay, well, on a monthly basis, how much traffic, you know, how much is going to the internet? And another use case of this that we found out from talking to hosting companies is they often watch how much traffic customers are using going outside of their hosting environment. They don't really care so much about it internally because they've got the bandwidth for that, but you know, you pay for the pipe going out, so you know how much is being apportioned. Okay. So the question is, are the counters in perp mode? These counters are not. Other counters are, that's true. These are special counters. They're actually read with WMI or with PowerShell. So they're programmatically accessible. They're accessible via command line, but they don't show up in perfmon because it's, strictly speaking, not a perfmon counter. If it was a perfmon counter, it would have had problems migrating. Okay, another thing that we added in, and you know, I mean, you're aware already that we've had IPsec and we've had IPsec task offload. The issue, you know, and this is giving you machine-to-machine security, but what we weren't able to do before that we've added in new is actually chain that task offload through the virtual switch to the virtual machine. So now if the virtual machine is using IPsec, he can offload that functionality all the way back down to the NIC itself. And of course, that's a performance benefit for you. Curious question, how many people are using IPsec? Okay, good. Just so you know, if you're using direct access likes to use IPsec as well. It does require, obviously, that the NIC have enough SAs on it to support enough of the machine. Yeah. All right, let's talk about network virtualization. This is a really cool new feature, and I'm only going to scratch the surface on this a little bit. There is a whole separate talk on this. I believe Sandeep Singhal is giving probably tomorrow. I'm not sure of the schedule. But what network virtualization is network virtualization is a kind of a new mechanism to separate tenant networks and allow you to keep your IP addresses on those virtual machines and let them still migrate around within the data center. Also ignoring the boundaries of subnets. And the reason it's ignoring the boundaries is because the subnets are normally dependent on the IP addresses, but in this case, we're actually doing this based upon a new concept, a virtual subnet ID. Now, the virtual subnet ID you can think of as an extended VLAN ID. And traffic-wise, it's treated somewhat like that, but there's an additional step that happens here. So let's assume that we have a blue network with a bunch of machines on it, and we have a red network. And those can be intermixed, and they could all even be running on the same machine. But they're going to be totally isolated from each other because of this, because they're different virtual subnets. Okay, I think I have a demo for you. I'm not hearing audio.
In the following demo, we're going to show flexible VM placement by doing a cross-subnet line migration without changing VM's IP address.
Let me restart this so we get all the audio.
Hyper-V network virtualization allows customers to bring their networks into the cloud and not worrying about the physical network in the data center. In the following demo, we're going to show flexible VM placement by doing a cross-subnet line migration without changing VM's IP address and highlight several new features along the way. Here I have my physical network set up with two IP subnets, 192.168.1.0 and 192.168.2.0. These are the addresses used in the physical networks. And we have two hosts in the first subnet and one host in the second subnet. Let's switch over to the customer view. You will see that I have onboarded two customer networks. The important thing here is that each customer can now bring multiple subnets into the cloud. And we support forwarding without requiring an external gateway or router. This setup, we have 5 VMs for the blue networks. And you can see their corresponding IP addresses from the 3 subnets. And only one red VM, which overlaps in IP address with the first blue VM. To demonstrate cross-subnet line migration, I'm going to start a continuous ping between the 2 VMs while migrating the destination to a different physical subnet. Let's switch over to the VM view. Notice that the ping is from 10.0.2.2 to 10.0.1.4 across two virtual subnets, with the forwarding is done by the network virtualization module. Also note that with System Center 2012 SP1, we can now support VMs using DHCP to acquire IP addresses and network configurations through VMM. Now let's start the ping and switch back to VMM for migration. See that 10.0.1.4 is now in subnet 2. We can migrate this VM by simply dragging the VM to a different physical subnet. Start the migration. While the migration is ongoing, during the brownout period, the ping will continue to work. As the blackout period starts, we will see some packet loss because the VM is paused and removed from the source host and will be resumed on the target host shortly. Now the migration is done and VMM updates the virtualization policy. You can see the ping starts working again automatically. And we can see that the VM is moved from subnet 2 and is now in subnet 1. That's our cross-subnet live migration demo. Without changing VM addresses, and the network connections continue to work. Thank you.
Okay, thank you, Yushin. I've run this several times, and I'll point out that it's worked every time I've run the video. So one of the things that it actually uses for the network virtualization tag, virtual subnet ID, is it is actually using GRE encapsulation, actually a slightly modified version. It's been submitted to the standard body, which we call Network Virtualization GRE, NVGRE. What NVGRE lets us do is we keep the physical addresses, the PAs, also known as the provider addresses, constant on the hosts. And the VMs then have their customer address, that is the guest addresses, the IP addresses. And what is happening is when the packet is going out of the machine, just before it hits the NIC, we have a Windows NV filter, and it's actually encapsulating the CA packet in the GRE packet, which is using the PA headers. So there's actually kind of an address wrapping, if you will. It travels across the network to the other host. Host picks it up. As it's coming up through that WNV filter, actually then strips off the NVGRE, the PA part of the packet, and delivers the CA packet as normal right up. So this is a fairly flexible system. It has a lot of interesting benefits. There are perhaps several other network virtualization schemes, but this is the one that Microsoft has chosen to back. Actually, we kind of created this one because it is an IP address virtualization scheme. As you saw, you can have the same IP addresses in different subnets with no collisions. You have total isolation. And that's this is pretty common, right? When you have multiple networks, multiple tenants in the same machines, it's pretty common for everybody to say, gee, I'm going to use a 10-dot address space. Well, obviously, that's going to cause collisions if you've got multiple 10-dot addresses on the same machine. But with this, you avoid those collisions. And as you saw, you can migrate across the subnets because, again, your boundary is a little bit different because you're using this virtual subnet ID. Is there more here? Let me just back up a second. There's probably another item or two I want to add to this. We are also working with some of the partners on creating NVGRE gateways, network virtualization gateways, and the purpose of the gateway is to let you take those legacy structures, such as printers, storage perhaps, and rather than having to convert them over to understand NVGRE, you put a gateway in front so they retain their physical addresses as they do today. That lets the VMs then go ahead and talk to them in this scheme, and the gateway does that translation for them. So look for those to be coming out. Okay, a couple other ways that you could do isolation. One that's kind of popular, particularly among web hosters, is private VLANs. Private VLANs, if you don't know, have really three modes of machines or VMs that you can put on them. You could have a trusted or machine. You could have a isolated one, or you could have a community one. Communities can all talk to each other. Isolated can't talk to anybody but to the trusted entity. These structures allow you to set up multi-tier networking structures pretty fast. Each PVLAN network uses 2 VLAN addresses. The other thing we put in was DHCP guard. I don't know if you're aware of this, but in Server 2008 R2 SP1, we had added ARP poisoning. That is the ability to kind of protect against a VM using rogue ARP responses. We've added actually router guard, and we added DHCP guard. DHCP guard in 2012 lets you essentially just set this flag that says, for this VM, I don't want to allow him to act like he's a DHCP server. Don't let him respond to the wrong queries. Don't let him send out the wrong queries. It'll drop those packets if it attempts to do that. All right, let's talk about predictability. So, QoS. Quality of service is always an interesting thing, particularly when you've got multiple tenants and multiple machines within the same. There's really 2 modes that we have. We have minimum bandwidth and maximum bandwidth settings. The minimum bandwidth settings say, I guarantee you X amount of bandwidth. And the maximum bandwidth says, you're capped. You can't use over this much. So you might use the minimum bandwidth to make sure that that your SQL server gets enough bandwidth all the time. You might use the maximum bandwidth to make sure that certain workloads don't exceed their quota of networking and start impinging on everyone else. The nice thing about the minimum is that while it's guaranteed the minimum, there is no maximum unless you set an additional maximum on it. So, as much bandwidth is currently available, it'll go ahead and use. But he's guaranteed of getting that minimum. A couple other things is the minimum and maximum. You can also specify some of these in either absolute bandwidth, or you can specify it as a percentage, a weight. Weight is kind of handy when you start talking about a team where you might have a NIC that fails. So rather than worrying about the overall amount of bandwidth that's now reduced and somebody would fall off the edge if they were absolutes, if you use a weight, it'll make sure that it apportions the bandwidth accordingly for those fellows. And I have a QoS demo. We got sound up on this?
Hi, I'm going to show you a demo about quality of service. Here we have a VM running on my machine. We're going to double click on the VM and go take a look at it. Here's the VM. On this VM, we're going to open up a file share that's been mapped to a share on the network. We're going to take this very large file. We're going to copy it over the network. And let's take a look at the network performance. And it's around 40 megabytes per second over there. Now, what we're going to do is open up PowerShell. And as we open up PowerShell, we're going to apply a PowerShell command to rate limit this VM. We say set VM network adapter maximum bandwidth 500,000 bytes per second. So I'm going to press return. Let's take a look at the performance for the network copy now that we've applied maximum bandwidth. As you can see, the rate falls. It's about 15, 10, going down further. And you can see the direct effect of the rate being limited on this VM's performance. We're going to go back to PowerShell. We're going to set the maximum bandwidth now to 0. Now, it doesn't mean no bytes per second. It rather means going back to unrestricted. I'm going to go back to the VM now and take a look at its network performance. Let's look at it carefully. And it'll take a while to react. As you see, the limit has been removed. The transfer bandwidth now goes back up to where it was before. Now, we're going to try that one more time, just so that we're sure it's not a fluke. We're going to go back to PowerShell. We're going to set it to 500,000 again. We're going to set it. Let's go back, look at the transfer rate. It falls yet again. And so this is a graphic example of maximum bandwidth in action. Now we're going to go back to PowerShell one more time, just to set it back to unrestricted by setting the maximum bandwidth to 0. And we set it, and let's go look at the response again. It comes back up. Now, I could keep doing this all day, but I think you get the point. Thank you. Hi, I'm going to show you a demo.
Yeah, he was going to do it all day, huh? All right. All right, let's talk about the way that Quas actually does some of this stuff. So one of the interesting things that you might have typically is that when you're setting limits, you're going to set the limits probably on the VMs that are important to make sure that they get the bandwidth that they want. But if you've got a lot of VMs, there's probably a group of VMs that you aren't so interested in having to try and set the bandwidth on. Maybe it's even hard to kind of figure out exactly what you want. It's okay with you if they kind of are in some pool of bandwidth. Well, there is a default queue. So that would allow you to set that. And then you can go ahead and set the individuals. Trying to remember what this slide is telling me. Okay, so there's this use case is saying if I'm doing wireless or if I'm doing WAN through a service that I have to pay for, that I can limit my bills by making sure that I put appropriate caps onto the system. All right, let me shift gears again. Another performance thing that we put in is data center bridging, a special type of Quas. If you're not familiar with DCB, DCB is supported by the hardware in part. What the hardware does is it actually has multiple queues, and these queues that are in the NIC card are assigned various priorities. And what we've done is we've set up some APIs that let applications set that, and then based upon the priority tag that's actually put into the packet, it'll get routed to the appropriate queue. So in this way, I could have, say, storage traffic have a priority. Or maybe I want to make sure that my live migration traffic, probably not, but point is that I can pick a flow of traffic that I want to give priority or multiple and send them to these other priority queues. And the NIC will actually then do the work of making sure it balances out the various priorities. There are both File I/O and WinSock APIs that can talk to this. The File I/O is interesting, and you'll notice what it's. These APIs are actually talking to the kernel mode RDMA. RDMA is a bypass of the TCP stack of sorts. It's actually offloading, it's using the stack on the NIC card as opposed to, and you get actually much faster I/O. We actually utilize the RDMA for SMB traffic in Windows Server 2012. Okay, let's talk about some of the scalability enhancements that we put in. Obviously, these are intended to enhance the operations. One of the things that we put in, and this is actually a rather big feature, is single root I/O virtualization. If you haven't heard about SRIOV, it is a PCI SIG standard. What it does is it bypasses the Hyper-V switch and allows a virtual machine to talk directly to the hardware. And you can have multiple of these. So let's say, for example, I could have a NIC that might support 63 virtual functions. That means 63 virtual machines can be talking to that card at the same time that there's one primary function talking to it from the virtual switch in the Hyper-V host. What this really gets you, or gets you close to, as I like to call it the holy grail of I/O, it gets you that near native I/O speed, or as close as you can get to it on a virtual machine these days. So there's a lot of pieces that are into this that you need to make it work. First thing is you got to have the physical hardware has to have a chipset that knows how to support SR-IOV, something like the more recent Xenon chips. The other thing is that it needs to have BIOS updates for SR-IOV to work, and it has to have a NIC card that knows how to do SR-IOV, because it is essentially an SR-IOV function, a NIC hardware function. There's a lot of work that we've done in the OS, both in the virtual PCI, in the virtual drivers, etc. So this, okay, I'll just leave it there. We did a lot of different things to make sure that this thing could work, and there's still some edges to this in the sense of when you can use it and when you really can't use it. But the big benefit that you get is that it's obviously reducing CPU because you're not processing all that traffic in the host. It reduces latency because the traffic is no longer having to hop through the host to get out. It goes directly out. And because of the first two reductions, it actually ends up increasing the network throughput overall on the network card. So it's a great benefit. Now, here's the caveat to it. If you use SR-IOV, you can't really have any policies applied in the virtual switch because you're bypassing it. What we've done to safeguard that is if you set a policy, like if I set a QoS policy, or if I set an ACL, or any other switch policy on that VM port that's currently doing SR-IOV, it will revert back to the software path. One of the beauties that we did is that the SR-IOV enablement is essentially a hint, if you will. In other words, if I set it on and everything is right and the resources are available, the NIC or the virtual machine guest will get SR-IOV and will use it. If the resources aren't there, obviously it won't get it and will continue over the software path. Interesting aspect of this is that because we revert the direct path back to the software path when we begin a live migration, it means that I can live migrate any machine that's SR-IOV to another box, whether that other box has SR-IOV or not. If it doesn't, it will continue to function in the software fashion. If it does, it will attempt to use the SR-IOV. That, assuming the resources are available, it will go ahead and allocate the SR-IOV channel on that target box. Excuse me. Here's a pictorial description of kind of what happens. A little animation. All right, so this is the normal way it works in Hyper-V today. This is the software path. Any traffic comes in from the bottom, goes through the switch, goes across the VM bus to the virtual machine. If I'm able to use the hardware path, then what's happening is that the the packets that come in are indicated straight up to the virtual machine, and these should really be double path arrows, if you will, because the same thing. The virtual machine talks directly to the physical NIC. By the way, the Hyper-V switch remains and continues to talk to the NIC regardless. In fact, the way it actually works is that this is a data path for the virtual machine. The control path is still routed software back through the virtual machine down to the physical NIC. The reason for that is that you want the control path to the NIC to always be trusted. And so if the virtual machine needs to do any kind of configuration, it would have to ask the Hyper-V switch first, and if it's allowed, it would happen. The most common reason, actually, that a virtual machine would want to ask a control question would be, say, what's my MAC address? In which case, it would send a packet actually over to the software side, and the Hyper-V switch would then talk to the physical card, get the reply back, and send it back over the virtual PCI bus, actually, in this case, to the virtual machine. Question?
We have two virtual machines to want to talk to each other. How this happen in SVIO?
You're asking if there's two virtual machines and they want to talk, and they're talking to each other, how would that happen? The answer is that every SRIOV NIC has what we call an embedded switch. That is a switch inside the physical NIC, and the linkage would be done in the card. So in that case, VM1 would send a packet down directly to the NIC. The NIC would, in its embedded switch, route that back over to the other channel, which would then send it back up to VM2 directly. Good question. Too much animation. Couple of caveats to tell you. Because of the way SRIOV works, at the moment we do not support teaming of SRIOV NICs in the host partition. It is possible, if you want to do teaming, to do the teaming in the guest, and this is an example of the guest. So the white box being the virtual machine, the guest. You could do a NIC team, and you could have two separate SRIOV NICs, each with a virtual function back to that machine. Notice that this also implies that there's also, in the host, two separate virtual switches, each having a separate software path to the individual virtual function NICs. Any questions on that? Okay. Okay. Yet another video demo. I promise this is the last.
Hi, I'd like to show you a demo of single root I/O virtualization. Here we have a server running Windows Server 2012. We're going to click on Hyper-V Manager, and we're going to look at the server. It's named 0601. This server has a virtual machine running on it. Let's connect to this virtual machine. And we're looking at the virtual machine. Device Manager. The Device Manager shows an Intel 82599 virtual function. This means that this host has a SRV capable NIC, and the SRV capable NIC has a virtual function that's assigned to this particular virtual machine. Let's go to the Hyper-V Manager now, and let's move this virtual machine. We're going to move this virtual machine to a different host, this 27W450602. Now, this virtual machine is interesting. I'm going to move only the virtual machine. It's interesting because the new host does not have a SRV capable NIC. So the question is, can you take a virtual machine on which a virtual function has been assigned to it, on a host that has a SRV capable NIC, to another host which does not have an SRV capable NIC? Will that work? Well, as a matter of fact, we've done a lot of work in Windows Server 2012 to take care of that eventuality so that you can take a VM and move it. Now let's go back over here. Let's look. The new virtual machine has moved to 0602. We're looking at the Device Manager, and as you can see, the Hyper-V Network Manager over here in the network adapter indicates that it does not have a SRV virtual function. So there you have it, folks. You can take a VM, you can move it, you can have performance as well as flexibility without any compromise.
Okay, SRIOV. Okay, in Server 2008 R2, we introduced Virtual Machine Queue. Virtual Machine Queue is a capability that allows the NIC to actually do some computations looking at the header, much like an RSS would, and make a single indication up to the switch of where this packet is supposed to be routed to, which VM it's assigned to. And what this did is this streamlined the processing so that packets could quickly pass through the switch and go right to the VM. It's a performance enhancement. But we found a little interesting side piece to it, and that was if you assign, let's say, 4 cores to that host, and so and say, yes, use these for VMQ, it will spread the traffic across them, indicating them to, round robining, kind of indicating to those individual cores. But the performance gain, you get a nice performance gain by separating the traffic and balancing it across the multiple cores. What happens if I only have a light amount of traffic? Well, the problem was there was almost more overhead spreading the traffic around than it would have been to have just processed it on a single core. So we made it dynamic. So here we go. If you don't have any VMQ, all of your traffic is being processed by this one core, even though you may have allocated 4 to your machine. So that's not great. That's kind of a bottleneck. So if I say, well, I'll use VMQ. By the way, we're now calling previous VMQ static VMQ. Say, well, okay, I can dump this traffic across these cores, and I get a definite performance benefit out of it. But what happens again when I had more traffic? Well, what we did is we made it dynamic. By the way, there's nothing you have to do to enable dynamic. If VMQ is on in Server 2012, it'll automatically be dynamic. So if there's only enough traffic for 2 cores, then that's how many you'll use. And if as it needs more, as it needs less, it'll go ahead and dynamically do that. We always advise people to turn VMQ on. Okay, so let's see how to explain. Are any of you familiar with data center TCP yet? Okay, a couple. Conceptually, the idea is, what do I do if my switch doesn't have a whole lot of buffer space, my physical switch, and the stack, the TCP stack, is talking to that switch and sending packets. And obviously, it's going to get to a point where it's not going to accept the packet, but there's this, it's going to drop the packet and do a handshake, say, retransmit and whatnot. And that actually has kind of a negative effect, right? That tends to slow down the traffic that's getting through overall. So what data center TCP does is it uses an ECN, an explicit congestion notification, that the physical switch can actually send back to the host stack and say, hey, I'm full, could you hold off? And by doing so, it actually means that it's not going to be sending packets that are going to be dropped, so it's not going to have to go through the retransmission. So it actually increases the efficiency, and you actually get more traffic through your switches. By the way, it has a side benefit in that you actually get to use more economical, smaller switches, if you wish, in your network. So here's an interesting graph. I think this picture probably tells it. You can see that if with just regular TCP, that it is no ECN, that you get your traffic kind of bouncing around based upon when the switch buffer fills up. If you use the ECN, and by the way, this does mean that the switch has to be ECN aware, capable of sending the ECN bit back, you can see that it actually evens out the flow now because it's now regulated. And you're actually getting more throughput through. Any questions on this? Okay. Yes. On by default, but of course it does require that you have a physical switch that is ECN capable. Here are a couple of switches that we know that actually have the ECN bit and will take advantage of this. There is a indication too that you can use here. Note the GetNet TCP connection will indicate whether or not DC TCP is available and being used. Okay, extensibility. So let's talk about this. This is the big green box is a blow up of the Hyper-V switch. So we're now calling it the Hyper-V extensible switch because we did a lot of work to put a networking stack into the inside of the switch. So just like you have a network driver and a protocol driver, and you can put in filters and build your network stack, you can do exactly the same kind of thing now inside the Hyper-V switch. And to distinguish the filters and such from what we put in the Hyper-V switch, we refer to those now as extensions. However, programmatically, they are using the same API model. So there can be capture extensions. These are extensions that do monitoring. You can, I want to build a network intelligence app, and it's an app that's going to just watch traffic. He's not going to drop anything. He's not going to modify anything. He's just going to look at the traffic and maybe send an indication off to my collector where I'm actually, plotting how we're doing. Another one, of course, is firewalls. We have a Windows filtering platform. We've built actually our own extension. It's a filtering extension that sits in here. And in this case, it allows third parties to use the WFP API set that they're using for things like antivirus packages and such today. Now you can insert it in here. By the way, one big advantage of having extensions is that when you look at if I have these two VMs on the same machine, if they were talking externally, I could always put filters above the NIC on the outbound path and capture the traffic. But if it was VM to VM, I would never see the traffic through those filters at the bottom. Now, by putting the filters in the middle, I can now do full isolation of the traffic. I've now seen full force, everything that's going through the switch, even though it's even VM to VM. So as I mentioned, you can also write an NDIS, the Network Device Interface Specification Filtering Extensions. And the biggie really for me is the forwarding extension. This is kind of the full thing. WFP and filtering extensions can modify traffic. They can drop packets, obviously. You have to do that if you're doing filtering. Forwarding extension can do all that plus a lot more. Forwarding extension actually takes over the forwarding rules of the Microsoft Hyper-V switch and implements them itself. So that means I can now, by inserting the forwarding extension, transform the Hyper-V virtual switch into somebody else's switch. And the classic examples of that is we have NEC, who's doing an OpenFlow switch. We have Cisco, who's doing both a Nexus 1000V switch, as well as for their UCS hardware, a forwarding. The UCS system also uses SRIOV. And they actually, it's because of the UCS hardware itself. Cisco's actually able to do some interesting things, including teaming their own SRIOV NICs. Examples of capture traffic, SFlow from Inmon. And WFP example, we have Five9 who has the virtual firewall. By the way, Five9 Cisco are here and have booths in the exhibit area. And we have another talk just on the virtual switch extensions this afternoon at 2:45. So there were some key tenets that we used when we built these to, what do they really have to do? Well, first thing was that they have to be extensible, not replaceable. We know our competition has a way that, you could replace the entire switch. But that means you got to write an awful lot of code, and you have to understand how you talk to VMs, things like VM buses, virtual PCI buses, etc. We didn't want to have our partners have to do that. We also wanted to reduce the overall code footprint, so we made sure that it was extensible. That is, you just write the functionality that you want to add. It's a pluggable architecture. All of these things become first-class citizens of the system, meaning that things like NIC offloads and live migration, they buy for free. There's nothing extra they have to do. We use the same API model that we've been using for NDIS and WFP. Those are exactly what filtering and network drivers have been using all along. Been out for over a decade. We built a brand new logo. Obviously, extensions need to be tested well and before they can get a certification. So we built a new rich logo certification program around that. And we added some other things to it in terms of unified tracing, event tracing, even through the virtual switch and in between extensions to actually make it easier to diagnose when something's going wrong, which means shorter downtimes when you use these. Excuse me. All right, let's talk about connectivity. So, so if you're doing remote access into the cloud, and think of things like direct access, one of the things that came up was, well, what if I've got two different sites? You know, how do I talk between these two? And the old way used to be that you'd have to put some servers in between to connect these two sites together. He said, you know, we're getting into a world where people are going to be migrating between the private and the public cloud. We need to make this a little sharper. So for 2012, we've actually coalesced this, that same server that can talk between sites is also the remote DA server that you talk to. So that's a big improvement. We've also done a lot of work to make it easier to deploy direct access. How many of you have used direct access? How many of you have had problems deploying it? Yeah, okay. The honest ones, okay. Yeah, so anyway, I think you're going to appreciate what we did there. And obviously, the last thing is just manageability. And if you haven't heard this yet, you've probably heard it multiple times that that everything you can manage using PowerShell. It's also scriptable using WMI as well, because we built WMI underneath all the PowerShell. But PowerShell is really the big thing that's been added, and there are probably things you can do only in PowerShell that you can't do in the UI. And it's simply because there are so many different options. You know, the UI is really intended to make it easy for people to come up and manage their system. The PowerShell is there to really give you the fine-grained control that you've been asking for. Hyper-V metering, we talked a little bit about this for the usage models. One thing to tell you, I mentioned about this actually, is that what we do with extensions, we actually take the configuration data, even though it's custom configuration data, and make sure that that's kept with the virtual machine configuration data so that it migrates. But there's one more thing we do. What if the extension, let's say I'm doing well, let's say it's some kind of a antivirus detection filter, and it's keeping count of how many, or maybe it's keeping a track of some names of viruses that it sees. Well, you'd want to make sure that you migrate that you don't lose that. So that's what we would call kind of real-time data. So before we do a migration, we actually ask the extension if it has that kind of information, and let it actually give it to us and move it over to the second machine. Is it possible to migrate a machine between different hosts with different extensions? Yes, it's also possible to prevent it from. There is a flag, or a property, if you will, that you can specify on a per VM basis of saying that a particular extension is required. In other words, consider it mandatory. Let me give you a good example of the two differences. I might have, say, an S-flow where I'm just monitoring traffic. That might be optional. It's nice to have, but I don't absolutely have to have. Like if I had a disaster recovery situation where I wanted to move to another machine in my DR center, I certainly don't want to be blocked by the fact that extension isn't there. But if I'm using something like NEC's OpenFlow, well, that's my router paths, right? And so that should be really mandatory, because if I move to another host, I want to make sure that I'm on a switch that has that same OpenFlow extension, so he can continue to route the packets the correct way. So I would call that one mandatory. And what will happen is, if I go to migrate that VM over to that machine and the mandatory extensions are missing, it will be rejected and it won't migrate. Extensions can also do the same thing with regard to resources as well. Okay, IP address management. So this is an area where we've gotten a lot of feedback in the last couple of releases, and so we actually put a fair amount of work into trying to integrate some of the problems together. I mean, you know, you have an IP address. You have static addresses or dynamic addresses. You're trying to track them. You've got a DHCP DNS server in the middle, and you know, how do you troubleshoot and audit and watch all that? Well, let me just kind of put some of these up here. So IPAM is essentially the collection of the tools that integrates all of this and lets you track this and present it in a nice, friendly fashion. So automatic discovery of your DC, DHCP, DNS servers. Then, of course, there's the address space management itself, whether you're using IPv4 or IPv6. Centralized configuration and update of both the DHCP and DNS servers. And finally, a visible audit trail. So these are kind of your IPAM pieces. So this is new functionality to help you manage your enterprise and data centers a little bit more effectively. Oh, let's see. I mentioned PowerShell. I mentioned that we have unified tracing. One other is port mirroring. So port mirroring, you're probably already familiar with port mirroring or span functionality. That's something new we had added in the Hyper-V switch that essentially lets you tag ports that you want to be copied to a monitor port. So any traffic that's flowing takes a copy of it, sends it over to the monitor port. The monitor port can then decide what kind of analysis it wants to do on that.
Where monitor ports should be located? Inside the host or outside?
The monitor port must be one of the ports on the virtual switch. So any what that VM does with it that's on the monitor port is obviously up to it. So if it wanted to get it external, it would have to make the linkage. But the intent is really to monitor that traffic. You can think of this as being a good construct for something like a virtual appliance that's looking for intrusion detection, for example. Okay, so I think I've covered all these things. There are some related sessions. There are partners out there that can be visited. Let's see. And I'm supposed to tell you, please submit your evals. So, questions? Yes, please. What happens to a VM when you do the port? Obviously, you would have to have the same port mirroring structure on the two machines, on the two hosts. No, it will migrate. The general concept for live migration is you don't want to stop a live migration unless it's a resource issue. In the case of something like port mirroring, that's really not. We didn't think of that as actually being a blocker for a live migration. Is it possible to set the port ACLs based on VLAN? I'd have to look. Off the top of my head, I don't know, but we could look quickly at the PowerShell and see if there's settings in there as well. Any other questions? Okay, thank you very much.